What's up, guys? Today we're starting a video on structs. We're discussing structures. We're mainly going to be focusing on C++, the syntax in C++ and all that. You could possibly apply the things to another language, but I mean, yeah. Yeah, so but like even if you don't code in C++, feel free to watch the video. Maybe you might learn a thing or two. So let's jump straight in. What is a structure, right? And what are they used for? A structure is a user-defined variable, um, which allows you to store multiple different variables or multiple different values under a single within like a single variable, quote unquote. And these values can be of different types. That's something that's quite important to note. So let me give you an example. Let's say you wanted to store the name, the age, and the height of a person. You could go about that in the following way and say string name is John Doe, age is 100. Let's say John Doe is 100 years old, and the height is he's 2 meters. The height we're going to store in meters. So yeah, you could do it by storing them in three separate variables, and that's okay, I guess. But if you have many different variables or many different um people whose information you'd like to store, you saying person one, person two, name, and having to each time have to go and declare the whole thing, it can be a bit tedious, and it can be repetitive and can lead to errors and all that stuff. So instead, we have what we call I don't know why I raised that. I can stay. We have what we call a structure. We have this single variable under which different variables or values rather can be stored. So we have this struct person, and then we have these things which are called attributes, which are the attributes, or I think they're also called member variables. I say members. And then you have the name of the person, the age, and the person's height. And in C++, the way you would go about accessing it, you say person. Oh no, it's a person. Actually, we'll get a bit more into this. First, you have to like create an instance of it, and then you can say person. Oh, that can be a bit confusing, but still, person name is equal to Jared, and then yeah, that's how you could go about it. But for now, don't worry too much about that. I'll explain it a bit more in a few minutes. So let's look at what's the difference between structures and arrays. If you remember what I said earlier, what's important to note about structures is that they can store multiple different types. Let me just specify here multiple different types. Whereas with arrays, you can only store one type. Right? Everything has to be of the same exact type. If you have an array, it has to be of type, maybe you say type char, maybe type bool, type int, type float, whatever it is, it has to all be each and every single element of that array has to be of the exact same type. You cannot have let's say you have some array, you can't have element one being, you cannot say this like string, let's just put that in there, and then 2 3.14159. Like you can't have a double in that element, and then can't have a double there, and then oh sorry, a string here, then a double there. That does not work. But for a structure, you can have every different type that you want. You can have a string, int, bool, and in fact, you can have another struct. You can have a different struct, your own defined struct within a struct. And we'll get into examples of that where you have a struct within a struct, and then yeah, that can go to as many levels of abstraction as you want, I guess. As long as there's enough memory, you can have a struct of a struct of a struct, and then you can also have a struct of arrays. You can have a struct, and then which has as its member variables, an array, and then this array, in fact, could be an array of structs, and you could even have point and a struct with pointers. Which reminds me, I should probably come up with a video with pointers. And then that pointer could point to an array of structs, and yeah, it can get extremely complicated and confusing. But I'm planning on going into all of that detail. I say detail to sound fancy. Detail. Okay, so how do we declare a struct in C++? So the way you do it, this would usually go, I should probably note that this would go above the main function, and it would go, or in some header file. I'm not going to do a video on header files. I'm not going to give an explanation of header files now. Maybe I'll do a video of it in the future. Don't mind my typing in the background. I'm just trying to go to Visual Studio so long, because guess what? This video is going to be different. So I'm going to give you guys some live coding examples. So you start with a struct keyword. You see here, the struct keyword. And then the name of the struct, the name of the data type that you're creating, the complex data type that you're creating. And for whatever reason, the first letter of structs tend to have a capital letter. I don't know why. It is what it is. So then you have this here, curly brace, then you have the first attribute, you have the attribute's type, then the name of the attribute, and then a semicolon. Right, it's important, it's a semicolon, not a comma. Okay, and then you have the next line, which follows the same format, the type, the name, semicolon. Just as though you, oh my gosh, just as if you were declaring a variable. And then the third one follows the same format, then the closing bracket, and then this semicolon right here. This semicolon, easy to forget, especially if you, like me, and you have to write exams on paper. I'm almost 99% certain that I forgot that there's semicolon in one of my exams. Anyway, so also something that I should tell you is that just because you have declared the struct does not mean you can use it immediately. It is just like essentially like a variable type, just like how you wouldn't be able to say float equals to 3.14159 what the rest of pi. You wouldn't just be able to say person is equal to Jared, let's say I'm 100, crazy, and let's say, not even let's say, I am 2 meters and 500, not 500, I don't know, 2.5 meters tall. Yeah, so you cannot say that, right? For the same reason that you can't say that, you have to give it a name. And what we call that, creating an instance. You could say person one, right? So you call it creating an instance. How do you create an instance? Here, this is an example. Creating an instance of a struct. So you say hashtag include iostream. Then okay, this is just general C++ code, the regular. And then you say person one. This is the name of the struct. If you go, we could draw this line all the way back up here, to where we gave the struct this name person with a capital letter, because C++ is case sensitive. And then here, this is the name of this individual variable that you, and then, well, like I told you previously, in order to get the value within there or to manipulate it or whatever, you use what you call the dot operator. You say the name, let's say name, oh, there it is, name dot attribute. That's how you do it. So you say person one dot name is equal to Jared, and then to output it, you would say cout person one dot name end line. By the way, the reason I don't have to put like std dot dot, for those of you who aren't very familiar with C++, is because I have this thing using namespace std. So yeah, then return zero. Okay, yeah, that's always. So let's jump straight into the Visual Studio Code, and yeah, I'll give you. So guys, here we are in Visual Studio Code. As you see, we're in the main file. I have declared this struct here, the person, just as in the previous example. And here in the main function, we create the instance of a struct, right? We say person one, and then there are multiple ways in which you can put the values into the struct. Um, so I'm going to show you the ways. This is the first way. You can say person1 dot name, person1 dot age, using the dot operator to put each individual attribute into the thing, into the struct, and then I don't know what I put this thing, and then here we just outputting it. So what we should expect the output to say name, John Doe, age 30, height 1.89. So let's, by the way, I'm using a makefile. Maybe if I actually one day understand makefiles, I'll make a video on it. But right now, I'm woefully too incompetent on them. Or I have a friend, maybe he'll do a feature on the channel and he'll explain them. Anyway, so here, as we expect, we have these things. We have the correct output. John Doe, age 30, height 1.8 meters. Okay, that's correct. That's correct. That's what we expect. That's right. So let me just quickly show you guys the other way to do it. Okay, so I have written out the other way of declaring the struct. So here it goes. You say person one is equal to, then you fill in each attribute in the corresponding order. What's very important to notice that it has to be in that exact order. Yeah, it has to be in that exact order. Just like, okay, so it has to say John Doe first, then the age, then the float. Like for example, if I had swapped these around, then it would cause problems. I'll show you that in a second. So let's just run this, and it gives us the same output, showing us that that method works. But let's say I said this 1.89. We don't have to worry about the fact that we are putting a float into an integer, because it will do the good old rounding and all that stuff. But we should expect, yep, it rounds down to 1, as C++ does, and the height is 30, and you see that's, even though we have outputted height, gives 30. So you see, that's what happens when you don't put them in the correct order. You have to put them in the exact corresponding order. Okay, on to the next example. I have a sneaking suspicion that the jump or the cut from the VS Code back to this explanation isn't going to be too great. My apologies for that. I'm still figuring out the whole editing thing. So now we're going to do an example with structs plus pointers. In this case, it's going to be a pointer pointing to a struct. The way it's declared, we're going to continue with the person example. The way it's declared is just like with a regular pointer. For example, if you said int ptr is equal to new int, yeah, it's just like that. It's just like the just like a dynamically allocated pointer in C. Yeah. So in C++. I don't know why I said in C. Okay, I guess also in C. Yeah. Anyway, um, yeah, just like with a regular pointer, it points to the actual thing. The pointer holds the memory address, and so since it's like a regular pointer, you would also have to dereference. As you remember, in order with a regular struct, when you want to get to the access the attribute, you use the dot operator. In this case, what you're going to do is, let's say we're using this person one as let's say we're using person one as the pointer, then you're going to say person one name. You're going to use this arrow. This is just the minus sign on your keyboard and then the angle bracket. Um, yeah, and then that's equal to Jared or whatever. Yeah. So let's just jump straight into Visual Studio Code now that you've seen that and try out some examples. So we're doing the pointer example now, and as you see, we've created the instance of the struct, but we're doing it um as with as pointer to the struct. And what I want you to see here is if you try to use the dot operator, um, the dot operator, it gives us an error. The reason is that it still needs to be dereferenced, and the way that you dereference it is you use a minus sign. Why is this thing tweaking? A minus sign and the angle bracket, the greater than symbol. Goodness, I forgot which symbol it was. So yeah, equals to Jared. Let me just fill the rest in and then we'll try outputting it. Okay, so I've finished writing all the other things. So we have Jared as name, 100 as age. Let's say I'm 100 years old. My height 2.5 meters. This is no joke. I'm actually joking 100%. Anyway, and as is always the case, you have to deallocate the memory. You have to always delete with dynamically what do you call it? Dynamically allocated memory. That is very, very important. So let's just go. Oh my goodness. I was supposed to remove that, but it's fine. Let's go ahead and run it. And as we see, it runs correctly. It says Jared is that, a name is Jared, age is 100, and height is 2.5. Okay, so I'm going to go back to the drawing board. Going back to the drawing, and we're going to go to the next example. Oh my gosh, did I run it without saving? Okay, but it's still the same answer. Anyway, yeah. Yeah, so welcome back to this to the drawing board as I called it in the previous clip. So now we're going to be changing the example just a wee bit, you know. We're going to be adding one more variable. Oh my goodness, I forgot something. I think this should have a pointer. It should be a pointer, yeah. So what we are having now, what we have now is a struct which has a pointer as one of the attributes. So we declare it in the same way, just like we have attribute number one. Here the type, name, all that, and then here we have std string star favorite food. Right, we're just adding the person's favorite food. It's a pointer to a string. Okay, so if you guys want a visual representation of what that looks like, let me just give you an example of how the struct looks to give you a visual understanding of that is redundant. Okay. I didn't do that well in English, but I know I did well enough to know that that is redundant. So we have this. Oh, I don't know if all of this is stored in the stack, but anyway, we have the pointer in the stack, and then that is pointing to the heap, which of course would store the actual variable. This would store the memory address of this here variable in the heap, and this would actually store the favorite food. Right, let's just say something generic, something random like pizza. Um, yeah, that. So this is just the visual understanding of how it goes. All the other ones are just here. You know, they're not pointers, but yeah. So we're back in Visual Studio Code, and now we have the example. We've already changed it. I've already changed it up. So we have the struct, and now we have the new and included. pointer to a string. So the way you create the instance of the struct, you say the way I've chosen to do it this way is person one, um, and then by the way, you may be wondering what's all this code here. This is just if you notice the file's name is random. I just do anything random. Whenever I need to practice, I just do it here because I don't feel like making a new make file. Because as I told you already, I don't understand make files well. Anyway, and you don't know the terminal commands and stuff. So anyway, person one name is John Doe. Person one dot age. Oh, as you may have noticed here, we're still using the dots operator. Sorry, we're gonna say dots operator. Notice the dot operator. We're still using the dot operator because it's not a pointer to the struct, but rather a pointer within the struct. Don't make that mistake, folks. Don't make that mistake. So we have over here just declaring the variables as usual. And then here, since it's a pointer, you have to allocate the memory. You allocate the memory, you say new std string pizza. And then here we've outputted it. And note that when you what's it when you want to get the value of favorite food, you deallocate it, but you do not deallocate it in the same way that you would deallocate it if the struct was a pointer. Again, guys, don't make this mistake. You have to notice these differences. If you didn't notice the difference, go back, watch the video again. I don't mind the extra watch time, you know. I'm joking. But yeah, if you didn't get it, just go back and look again. And as always, always deallocate the memory, folks. Always deallocate the memory. So let's just make sure this is saved, and then we're going to say make run. And as we expect, it gives us the name John Doe, age 30, height 1.8, and the favorite food as pizza 1.89. Sorry, the favorite food as pizza. Let's see if I can spell spaghetti. Spaghetti. You know what I'm saying? I was gonna say English was my strong spell, but spaghetti is not English, folks. Spaghetti is not English. I don't know why I'm testing it, so it should give a different result. But yeah, it gives that still. And let's just try for interest sake. Let's okay. Let's try not dereferencing it. If we let's say um favorite food reference. Let's just move this up a bit so you guys can see. Um, clear, and then we're gonna say make run. And as you see, it gives us the actual address at which the thing is stored as opposed to the name. So yeah, that's all for this example, and back to the drawing board as I've been calling it. Folks, you may be wondering why I'm starting off this clip with a picture of a spanner. It's because we are throwing a spanner in the works. Why is it so pixelated? It's because it's the only picture of a spanner I could get. So let's jump straight in. Structs plus pointers plus arrays. So we're going to start off with the struct with a static array. It's important to note that it's static. We're going to also do, hey, do I want to? Hey, do I want to? I'll decide. But for now, let's just look at the static array. So here's the declaration of the struct. Let me write in red so you guys can see nicely. I don't know. It doesn't actually do anything, but I like writing in red. It looks nice. So same deal. Oh, by the way, we changed the struct though, just because to have student would be a little bit more fitting for an array, because just a person, I don't know what would fit. Like, well, what would a random person have an array of? But for students, they have an array of grades. Let's say it's for different subjects or different classes, whatever on earth it is. Yeah. So you declare it just as you would a regular array. So you say float, the type, grades. Oh, by the way, I can't lie to you guys. I'll be very honest with you guys. I didn't want to come up with an example, so I asked good old Le Chat, as they call it. Le Chat in French actually means cat, but Chat GBD, you know what I'm saying? So yeah, I use ChatGPT to get an example, but I promise you guys, I know I understand the concepts. I just yeah. Okay, now I'm yapping. So yeah, it has five. What's it? We allocating it. What's it? Five traces of the size of float. One, two, three, four, five. Um, So inside the main function, we obviously, as usual, we have to create an instance of the struct, and then as usual put name, age, and now you could do this manually one by one, or you could use the usual method where you use a loop. But I'll show you. I guess I'll use the way with a loop in the demonstration if I remember. And then here, this is how you're going to output it, just in the same way that you input it. You say the struct's name using the dot operator in this case, because the struct is not a pointer. You only use that what, I can't even remember what it's called. You only use the arrow in the case where the struct is a pointer. Otherwise, yeah, you don't worry about that. Then grades index 0, and then that should output 90.05. Return 0, because this is the main function, is you always have to put return 0. And yeah, that's let's jump into Visual Studio. But anyway, we're doing the example where we have a struct with an array inside of it. In this case, it's say a static array. So as usual, we create the instance of the struct, and then we put the first two values, and then what this piece of code here does is different from the code that I had on the drawing board, as I call it. What it does is it just allows me. Sorry, I just had to plug in my laptop. It allows me to enter each name, each grade or mark, as we call it here in South Africa. Sorry, individually. Yeah. Okay, and then here this code here just outputs it. You guys can take a look, or alternatively you can ask ChatGPT and it might output something very similar, because I got this from ChatGPT. I won't lie to you guys, I got it from Chat. Got it from the shop. Okay, let's say the good old John, he hardly passed the first exam, or the first test, failed the second one, but then he was on the academic comeback. This man was cooking. This man was cooking. He got a 90 on the last. Oh wow. Let's just remove this, because now that looks awkward with a comma at the end. But anyway, it outputs just what we expect. Outputs just what we expect. So what I actually should have done, yo, anyway, yeah. Outputs just as we expect. Things work together. Yeah. All good. Back to the drawing board. So now onto the next example, which is a dynamic array of structs. So let's first look at how it would look in memory. Um, yeah, these things might not be fully accurate. These things, they just to give you an idea of how things look, you know what I'm saying? So in the stack we have, as with all dynamic arrays, we have with all yeah, you have a pointer in the stack pointing to some memory address in the heap, which is the first index of the array. And in this case, the first index in the array is a struct. Um and this struct, okay, I'll go into more detail. There's another diagram that I've drawn below that goes into more detail, but yeah, it's a struct, and then all of them are like this. All of them also have these, have each attributes of the struct and all that stuff. And then in the demonstration in Visual Studio Code, I'll show you guys how you actually put this into code. We are going to implement this with the student struct, the struct that we declared up there. Here, this here struct, we're going to implement it with that. So you guys may be thinking, wait, doesn't that mean we're going to have a pointer pointing to a dynamic array, and then within that dynamic array we're going to have one of the attributes being a static array? So yes, if you thought that, I don't know if anyone actually thought, maybe yeah, definitely someone thought of it 100%. It's not like I don't rate you guys, it's just I'm yapping. So we will have a dynamic array of structs, and each struct has a static array. Yeah, that's what I just said. Here I just said this is not exactly how it looks, just to give you an idea. So here we have in the stack the same. We have the pointer student pointing at the first index in the dynamic array, and then we have the attributes in the of the struct student, the attributes of the struct student, and then the grades here are pointing to this here static array. Maybe I should have specified over here that it is a static array. And then as I wrote here, it is the same deal for all of these. So these ones also have name and age and grades and as many as you would like. Yeah, basically as many as you would like. Depending on the limitations of your memory. So let's jump straight into Visual Studio and give this a try. Okay, so here I just included using namespace, by the way, using namespace std, just so that for the couts, for the outputting, I wouldn't have to write std for each and every one. So we have the same student struct as the previous example, and we have the good old uh, main function. So by the way, what I did here, I just made the number of grades fewer because I don't want to input 112 different grades. Then we have we made a constant for the number of students. We said 2, because again, I don't want to have a long thing. And some of you may say, you could have done this through the loop. I actually do not care, man. Like, I don't want to use a loop because then I must input each and every individual one by hand each and every time I want to run the program. No, 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 no. Nah, it's fine. So here we allocate the memory. Students, this the very important since it's dynamic. Yeah, it's a dynamic array. You have to put the star and then you say new students and then with the size of the array in here. And now here we just initializing all the values. By the way, this is inspired by my friend Nathaniel Paul. I felt like it sounds like such an old name. It deserves like the third or the first. Let's put him as the first. If you look at his marks here, he's the goat. So we'll put him as the first. I just thought his name sounded so royal, so English that I don't know. I just wanted to put it there because if he watches this video, it'll be funny. Anyway, then here we just outputting each individual thing. Now, if my editing skills are good, what I'll do is I'll put the image of the diagram I drew here, and I'll just speak about it. So as you see, this is basically the two structs, and then it has the information. It has the first struct, it's information, Jared, the name is Jared, the age is 30. That's not my actual age. Then the grades 90 and 86. Those aren't my actual grades. Nathaniel Paul the third. Okay. Then his age 28. That's not his real age. Then it's 95 and 96. He's cooking. He's cooking academically, folks. Anyway, and also here, as usual, always deallocate the always, always, always deallocate the memory. Don't have to deallocate the static array. Ooh, do you? I don't know. It doesn't really matter to me. If the computer crashes, it crashes. Maybe let me just put a new line here, sorry. Just to make things a wee bit more readable. There we go. So the name of the student one is Jared, age of student one is 30, and then it outputs it just as we expect. And yeah, and also what I want you to notice about the way in which we access that's actually why I'm doing this. This whole demonstration is so you can see how we accessed each thing, especially for the grades. Look, draw your attention to here. If you're looking there, look here. Okay, so it's students one, right? Because we're going into the dynamic array, and then we say dot, right? Because dot is this the student. The array is not an array of pointers. If we had declared this as this and this, then we would have to say, oh my gosh, then we would have to say that C doesn't give errors in that case. But we did not declare it as an array of pointers, it's just a dynamic array. So you say dot, we use the operator, grades, and then here, look, we also go into the first index of grades. So it's the first, or rather, it's the second index of the students array, and then the first index of grades, for second index of students array, second index of grades. Yeah. So I hope you guys get an idea, and hopefully, maybe I'll put the image back on the screen. Editor. I'm actually speaking to myself when I say editor. Put it on the screen. Yeah. So back to the drawing board. What's up, guys? I'm actually recording this the following day, but okay. So we're continuing. The next example is a struct of pointers to structs. So we're gonna have a struct which has a pointer, which has as one of its attributes a pointer which points to a struct. So it's gonna be struct yeah, struct. Okay, yeah. Sorry. Um, So we're going to be continuing the student example, but for the sake of simplicity, we're going to remove that static array that we had previously. So now it's just going to be these two attributes, the name of the student and the student's age. And then we're going to create another struct which has to go under it, since I'll explain why it has to go under it now. We're going to call it classroom. Classroom, we declare it the same way. We have some class ID. This just uniquely identifies the class. It could be class 1A or whatever the heck the class is called. So then we have this here, this is a pointer to a struct. And if you notice, I told you it has to go beneath this. It has to go after this. The reason it has to go after this is assuming these declarations are not like maybe in different header files or whatever. Assuming they're all maybe in this, assuming they are all in the same file, this one would have to go underneath this one, or rather, classroom would have to go underneath student, because it makes use of the student's struct, right? This if this were to be above student, then the compiler would not know what student is, because it has not been defined in that scope yet. So it's a pointer to a struct. And also, by the way, it can also be used as a dynamic array. That's one of the examples I'm going to show you guys. Let me just give you guys a quick visual representation of how this is going. Okay, so here I've drawn a diagram of this is let's say we have some instance of the classroom struct. What's it? We have created an instance of the classroom struct. So we have the class ID, which is here, and then we have the pointer, which points to some dynamic. It could be either a dynamic array, or it could just be a single, dynamic variable, which in this case is the student struct. And yeah, so as you can see, it points there, and then since it's a pointer, since this one is a pointer, it will have to be dereferenced. But classroom is not a pointer, so it don't have to be dereferenced. So how does dereferencing work in this context? You would only use the arrow operator for students. Let me show you what I mean. Let's say we have created an instance of the classroom struct called my classroom, and we're going to say, if we wanted to put the name of the student of one of the students of my classroom, we'd say my classroom dot student, and then here we would use the arrow operator, but here we use the dot operator, because like I said, this one is not a pointer and the student one is a pointer. But I'll show you guys an example in which this one is a pointer when I go into the VS Code example, or the live yeah, so not live, but yeah, the live example. So yeah, just give me a second and I'll come back with the example in which this is a dynamic array. So this is the example in which it's a dynamic array, where this student points at a dynamic array. So just like in the previous example, we have my classroom over here, and that point, and then we have the class ID, which I said stores has a unique code uniquely identifying the class. And then we have this student, which points at a dynamic array, points at the first index of this dynamic array of structs called of type student, of type student. And so the way the dereferencing with this one works is that since the brackets technically already kind of do the dereferencing, quote unquote, the dereferencing would look like this. Say, for example, we have my classroom. Let me just finish writing and I'll be back. Yeah, so we would have dot operators only, because this bracket kind of does the what do you call it, what's the word, the dereferencing. My goodness, hopefully I'll edit that out. The dereferencing for us. So then both of them are dot operators, and I'm sure there was a previous example in which there was a similar situation where we had the dot. Oh, I don't know if you guys could see that, the dot operators. And yeah, so I'm going to jump straight into visual. I keep saying this. going to go into Visual Studio Code, and I'm going to show you guys examples as well as one other example which I haven't shown here. I've declared this struct student, and as I said, I removed the grades static array because that would complicate things unnecessarily. Now we have this struct here, classroom, and we have this uh, member attributes. Oh, sorry, member variable slash attribute called class ID, and we have this pointer called of type student, which is from this struct here called student. Okay, so we go into the main function, and we create an instance of the classroom struct, calling it my classroom. By the way, if you're wondering why I didn't just say my class, because there's something called classes, and I don't want to, confuse anyone between that. Okay, so we just give a random class ID here, just say 123, and because student is a pointer, we're going to allocate memory. Oh, sorry, why did I say dynamic array? It just means let's just say allocating the memory. We're allocating the memory for the pointer of student, and so like I showed you guys in on the drawing board, for this one, for student, you have to use the arrow operator because it has to be dereferenced. Here, no dereferencing necessary because my classroom is not a pointer. Let's say my classroom was a pointer is equal to, oh my goodness, is equal to new classroom. In that case, you would have to put use the arrow operator, because it would have to be dereferenced. So that is why. So let me just undo all of that, and then we'll just continue the example, making it so now again it's no longer a pointer and all that. So good. But student is a pointer, so student has to be dereferenced like that. So student name is Jared, student age is 25. That's not my actual age. And the class ID, here we just outputting the different things. So sorry, okay, let's just run this code and see if it works. Mm, I changed the position of the terminal because on the side, I don't know why I had it in the side in the first place, but it's okay. So class ID is 123, name of students is Jared, age of students is 25. That is correct. That is what we expected. And yeah, so on to the next one. Let's comment all of this out. I'll be back. Okay, so here's the example where it's a struct with a pointer to an array of structs. And what you should notice, I'm not changing anything about the declaration of the structs. Since this struct, since in the declaration of the classroom struct, student is declared as a pointer. Nothing has to change. We can just use it as though it were a dynamic array. So firstly, as always, you create an instance. Oh, by the way, in the previous example, I actually forgot to mention this. You have to deallocate the memory. Like I say, always deallocate the memory, but it's okay. Now I've corrected myself. So we create an instance of classroom. Then we say const int. We make a constant integer for the number of students, and we say two students because I don't want to run this loop 112 different times. Then we say my classroom dot student. Again, we're using the dot operator is equal to new student, right? And note the way that we are declaring it. Note the way that we are allocating this memory. We have the brackets since it is a dynamic array. In the previous one, we just said new students. In this case, we're saying new students with a bracket and then the size of the array inside the bracket. Just giving us some free dynamic array revision. Um, and then here, this algorithm here just allows me to input the names and ages of the different students. In this case, it's just going to be two, so the thing's not going to run too many times. And here we just output it. So, and then here, as always, always deallocate the memory. As I say, guys, you always got to deallocate the memory. So let's just run this thing real quick. Make run. Oh, as you guys can see that I have a bunch of terminals open because yeah. So enter student one's name. Let's say student one is Jared. Enter student one's age, 25 again. Student one's name, Jared 2.0. Student one's age, 25 also. So sorry. The reason it's saying student 0 is because I forgot to increment it here. Sorry, it should say it should be I plus 1. And then here it should also be I plus 1. And then if I run it again, make Run. It should be correct this time. 25. So 2.0. 25, and there it gives it as we expected. So now onto the last example. This last example is going to be a pointer. This is the special example that I mentioned earlier. It's going to be a pointer to the struct which points to an array of structs. So I'll be back in a second. I actually forgot to do this. I should draw your attention to the dot operators. I use dot operators and not the arrow operators here because the what you call it, these brackets here kind of dereference it for us. Because if you remember with arrays, what that arrow just means, you're saying students get the address of student plus whatever I is, right? So it goes here and then dereferences it and then returns that value. So that's why we don't have to use the dot operator. Yeah, that's the reason. Okay, so we're back. We're back. You guys don't notice it. It just seems like there's really abrupt jumps, but I'm back with a different example here. Same structs, exact same, but this time we are declaring. Um, we are maybe this we should say allocating, but anyway, this time classroom is going to be a pointer, and you'll see how that affects things now. So we're gonna say classroom, my classroom, right, is equal to new classroom, but it's declared as a pointer. That's why you're saying, that's why we're declaring it like this. That's why we have to allocate the memory. Now, just as in the previous example, we have a constant integer which stores the number of students. And by the way, I'm in a rush. That's why I'm speaking so quickly because I have to actually go somewhere. But I want to get this video out for you guys. Anyway, my classroom, um, student notes. Note the use of the arrow operator. Let's just let's remove this. I just copied this straight from the previous example actually because I did not want to type all that out. So I'm going to say here, note the use of the arrow operator. I'm impressing you guys with how fast I type. Anyway, yeah, note the use of the arrow operator here because classroom is a pointer. Like I said, the only time you use the arrow operator is when the struct is a pointer. When what's remaining is a pointer. And maybe I'll do another example with the foot with where it's like double pointers and triple pointers, but I don't. For now, I'm not going to do that. So, and then we have here, this is the same algorithm just to enter the student's name and age again using the arrow pointer, the arrow operator here, and the dot operator here. As I explained in the previous example, the reason why we use the dot operator is because with arrays, what you're essentially saying when you have these brackets and this number is like if I say student, okay, student, that is basically saying student, saying dereference the memory allocation of student plus one, right? That's what it's saying. So that's why you don't use the arrow operator because it's technically dereferenced already. Um, but yeah, you guys, there's probably documentation out there somewhere. And then here we just output it. Then what's important here is the order in which you delete the arrays. First, you have to delete the student array. Yeah, first you have to delete the student array, then you can delete the classroom array. The reason is because um the stack operates on a first in last out principle. Actually, when I do my pointers video eventually, I'll explain that you have to first dereference the things that were allocated last, and then how do I say dereference? I meant to say deallocate. Then you can delete the things that were allocated first. And let's just run this and check how it works. Okay, so I've run the code here. It's just Jared. Oh, yeah, I can't type today. 26. That's again, it's not my actual age. 2.0. And why didn't it ask for my age? There's something wrong with the code. Hold on, I'll be back. Let me debug it and I'll be back. You know what I realized? I'm actually so silly, bro. The reason it did that is because there's a space here. You shouldn't. If I wanted to do it with a space, then I should have used the get line. But whatever. So what it did was it took two as the age of Jared 2.0. So, but anyway, so we say student zero. Again, I forgot to do the thing where I increment this, but I'm not going to change it now for the sake of time. Student one's name is Jared. Student zero's name is Jared. Student zero's age is 26, and it works just as we expected it to. We have deallocated the memory, and thank you guys very much for watching. This has been a very long video, and I've actually put a lot of effort into it. And I would really, really appreciate it if you guys would subscribe, hit the like button, and share this with as many people as possible. Um, yeah, share this with anyone whom you know might need it. You have a friend doing computer science, a friend learning to code, anyone, any. I literally do just share them, share it with them. Thank you very much, guys.